Sometimes when you have a quadratic, you just want to know the number of solutions or the type of solutions. So you don't have to use the entire quadratic formula to determine this answer. A real number is any number that can be represented with a decimal. The issue we have for the quadratic is you have a square root. Underneath that square root, you need a positive value or 0. If it's negative, you cannot take the square root of a negative and get a real number. The discriminant is the number under the square root. It does not include the square root. The discriminant is b squared minus 4ac. And the discriminant theorem will tell you how many and the type of solutions that you have. If your discriminant is greater than 0, so if your discriminant is positive, there are 2 real solutions. If I take negative b plus the square root of a number, I get 1 value. Negative b minus the square root of this, I'll get another value. Both of them will be divided by 2a, but there'll be 2 distinct solutions when I do that. If your discriminant is equal to 0, the square root of 0 is 0. So negative b plus 0 is negative b. Negative b minus 0 is also negative b. So you get the same solution. So there's only one real solution. And then if your discriminant is negative, there are no real solutions because you'll have the square root of a negative and there are no real numbers that will make that true. There are imaginary solutions. There's actually 2 imaginary solutions, but we're not going to get into those yet. We're just going to look at that as there are no real solutions for now. The solutions are your x-intercepts, and they're also called roots of the equation. So if your discriminant was positive, there would be 2 x-intercepts. If your discriminant is equal to 0, that means it's going to touch the x-axis and bounce off it, but not cross through it. And then if your discriminant is negative, it does not cross the x-axis at all. For examples 1 through 4, we're going to determine the number of x-intercepts, real roots, of each of the following. Recall the x-intercept is when you plug in y is 0. So in this case, my a is 3, b is 3, and c is 8. So squaring b, we'll do b squared minus 4ac. So when I square b, I get 9 minus 4, a is 3, c is 8. And you can type that in on your calculator. That gives you negative 87. So that means that b squared minus 4ac is less than 0. So your discriminant is negative. Which means there are no real solutions. Okay, and so for the x-intercepts, it's not going to cross the x-axis. On example 2, a is 15, b is 2, and c equals negative 1. And we're setting y equal to 0 in these when we solve them. My discriminant is b squared minus 4ac. That's how you find it. Square b, so that'll give you 4, minus 4 times a, which is 15, times c, which is negative 1. And when you type that in on your calculator, you'll get 64. This time, b squared minus 4ac is greater than 0. That means my discriminant is positive. So there are two real solutions. So there are two x-intercepts. On the next one, again, we're setting y equal to 0. A is 16, B is negative 72, C is 81. My discriminant is b squared minus 4ac. When you square b, you'll get a positive number because b is negative. When you square negative, you get a positive value. So remember, b squared is always positive. And negative 72 times negative 72 is 5,184 minus 4 times a, which is 16, times c, which is 81. And this time I get 0 when I type that in my calculator. Since b squared minus 4ac equals 0, my discriminant is 0. That means that there is one real solution, and it's going to touch the x-axis once. There's one x-intercept. On number 4. Again, y is 0 when we solve these. So a is 1, b is 7, and c is 1. So we have b squared minus 4ac for my discriminant. And when I square b, I get 49 minus 4 times a, which is 1, times c, which is 1. And that gives me 45. And on this one, b squared minus 4ac is greater than 0. My discriminant is positive. There are two real solutions. There are two x-intercepts. For number 5, we're solving number 4. And remember, our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What's nice about this is I can do the opposite of b, which we already found b was here, so this is negative 7. Plus or minus, I already found my discriminant. That's 45. So sometimes it's kind of nice to go ahead and find the discriminant ahead of time. So you can just plug it in there. And that's divided by 2 times a, so 2 times 1. You're going to get two solutions. Square root of 45 is not a perfect square. So we're just going to have our calculator estimate this to the nearest hundredth. So I'll do negative 7 plus the square root of 45. Make sure you put your numerator in parentheses or hit enter on your calculator before you divide it. So this will give you a solution of negative 0.15 and negative 7 minus the square root of 45 over 2. Again, put that in parentheses before you divide. Gives you negative 6.85. We have completed today's notes.